Welcome to the Common Network Threats and Prevention lesson. Click Next to get started. After completing this lesson, you'll be able to achieve these objectives. Identify common network threats, understand the effects and how to prevent threats, describe best practices used against network threats. Network threats are unlawful or malicious activities that intend to take advantage of network vulnerabilities. The goal is to breach, harm, or sabotage the information or data valuable of a company. Malicious actors also attack networks to gain unauthorized access and manipulate the same according to their intentions. The motivations can be political, financial, or retaliatory. Common network threats include spoofing, hijacking, replay attacks, transit attacks, and denial of service, DOS. Click the buttons to learn more about the common network threats. Spoofing is a threat during which the attacker impersonates an authorized device or user to steal data, spread malware, or bypass access control systems. The attacker is capable of spoofing any unique user or system identifier, like a MAC or IP address. During a hijacking threat, an attacker intercepts a connection to discover and potentially modify the initial two parties' communications. Man in the middle is an example of a hijacking attack. To prevent it, end-to-end encryption with multi-factor authentication provides confidentiality and validates the initial two parties. While an attacker performs a hijacking attack in real time, a replay attack is delayed. It intercepts a communication and maliciously repeats or resends the data later. For example, by fraudulently replaying an authentication, an attacker could access confidential applications. A one-time session token can prevent replay attacks. A transitive attack uses the trust chain between devices. If device A trusts device B and device B trusts device C, device A could then trust device C. If one device is corrupted, the other could also be attacked. You can prevent this transitive attack by implementing the zero trust concept. During a denial of service, DOS threat, the attacker attempts to exhaust the network resources and block legitimate resource requests. This is like a traffic jam on a highway that blocks emergency vehicles from access. An example of a DOS attack is when an attacker attempts to exhaust the network resources by using botnets. If the attack is successful, resources become unavailable and legitimate users are denied access. Click the botnet icon for more information. Examples of DOS attacks include flood attacks like Smurf and Fraggle attacks, and SYN flood and Christmas tree attacks, ping of death, teardrop, permanent DOS, and fork bomb attacks. Click the tabs to learn more about the different DOS attacks. The goal of flood attacks is to overwhelm a device. Usually a botnet creates the attack with connectionless traffic like UDP or ICMP. Click the different subtabs to learn more about the different flood attacks. In a Smurf attack, the attacker spoofs a victim's source IP to broadcast an Internet Control Message Protocol, ICMP packet to a network. After the attacker sends the packets, most of the devices in the network reply to the original source IP address, flooding the victim's device with traffic and reducing its resources for legitimate requests. Similar to a Smurf attack, a Fraggle attack spooks a victim and sends a spoofed UDP packet to the router's broadcast address. The victim's device is then flooded with traffic, reducing its resources for legitimate requests. A SYN flood is part of protocol attacks specifically targeting servers, proxies, or firewalls. During this attack, the attacker creates an incomplete TCP three-way handshake, allowing SYN floods to exhaust the resources of the device, which is waiting for half-opened connections. During a Christmas tree attack, the attacker sends out multiple TCP packets with the FIN, URG, and PSH flags set. These Christmas tree packets require more processing by routers and hosts, reducing their resources and potentially making them crash or reboot. A protocol analyzer identifies and analyzes these packets. While a ping is typically less than 100 bytes, a ping of death creates packets greater than 65,535 bytes. During a ping of death, the origin device fragments the packets before the transmission. When the target device reassembles the malformed packets, a buffer overflow or a crash can occur. A teardrop attack involves sending fragmented packets modified with overlapping and oversized payloads. When the target device tries to reassemble the fragments, the packets overlap one another, crashing the target network device. In a permanent denial of service, PDoS, the attacker exploits vulnerabilities of the device to replace its software by a corrupted firmware image, rendering the device useless. A reboot of the device is not enough. Instead, the recovery of the device requires a reinstallation of the correct firmware, or a total hardware replacement. A fork is a system call used in Unix and Linux systems that replicates an existing process. Because a fork loop consumes CPU and memory, a kernel panic can occur on the device, locking the system completely. A fork bomb continues to replicate itself through the child processes, depleting available resources and slowing down or crashing the system. To prevent DOS threats, network devices like firewalls can implement anomaly checks of the packets. This mechanism can block ping of death, Christmas tree, and teardrop attacks. You can prevent fork bombs by limiting the number of processes a user can own. To prevent Smurf and Fraggle attacks, routers no longer forward packets directed at their broadcast addresses. Also, to limit floods in general, firewall mechanisms like DOS sensors or network behavior analyzer using artificial intelligence keep the traffic under expected amounts. In addition to the previous prevention methods, two important best practices are to close unnecessary ports and fix known vulnerabilities. Neglecting these steps can provide points of entry for network threats, like leaving doors and windows open at home. To find open ports, a port scan like Nmap can provide a comprehensive list. If the unnecessary ports cannot be closed directly on the server, you can create a firewall policy that blocks access to these specific ports on the front firewall, such as FortiGate. You can identify vulnerabilities with a penetration test. The best practice is to update the network devices regularly with the latest patches. Like network segmentation or the implementation of zero trust principles, these practices are part of the hardening measures. Click the underlined term for more information. You have reached the end of the lesson. You are now able to define common network threats. Describe common network threats and their corresponding prevention. Describe best practices against common network threats.